give a brief explanation of what a swap is, um, you can imagine as an exchange of cash flows at specified future times according to specified rules. And it is an exchange of either an interest rate or a currency. Um, One big example, or one of the biggest interest rate swap used, is the plain vanilla interest rate swap. And to make it easier to understand, picture an agreement by Microsoft in which receives a 6-month LIBOR, and in exchange they pay a fixed rate of 5% per annum every 6 months for 6 years with a notional principal of $100 million. And this next slide indicates how the exchange is going to be. By giving the percentage of LIBORs, this will be the amount of income of or inflow cash flows, and this would be the outflow since they will be paying in a fixed rate and receiving in a LIBOR, and this will be the net cash flow when they receive after they do the exchange. So as you can see, since it is a semi-annual compounding, you can see that there are 6 transactions for 3 years. And a swap is typically used for converting a liability either by being from a fixed rate to a floating rate or a floating rate to a fixed rate. And it can also convert an investment so from a fixed rate to floating rate or a floating rate to a fixed rate. This is another example that could be done by exchanging interest rate from Intel to Microsoft or from Microsoft to Intel. Intel here will be paying, giving the LIBOR exchange rate, and the Microsoft will be giving to Intel the 5% fixed rate of the notional $100 million. So according to this, as you can see, Microsoft will be actually giving 5% fixed rate plus the 0.1% here, which is on basis plus LIBOR, because these two will be canceling out. And on the other hand, Intel would be actually paying LIBOR minus the amount that they would be receiving from the Microsoft fixed rate. And this part talks about the financial institution. Usually two financial firms doesn't actually swap with each other side by side. There's actually a financial institution that is involved through these transactions. So, and usually this financial institution receive spread basis of 3 to 4, meaning that it's from 3% to 4% of the exchange rate. So the financial institution, as you can see from the previous one, instead of Microsoft, instead of paying 5% fixed rate, they will be paying 5.015%, which is a half of the 3 basis and of the 0.3%. And here, Intel would be gaining, instead of the 5%, would be gaining 5 minus 0.015, which is a half of the 3 basis. And the reason why the financial institution received this amount of percentage is because they have to make sure that none of these two firms default throughout the transaction. So it's about like a guarantee for them to receive. Again, the other way around is for instead of transforming liability, they can also transform into asset. So instead of paying to the outside investors, they would be receiving And this is a picture that describes how they would be receiving those interest rates and then how they can actually exchange or swap those interest rates. As you can see, Intel will be receiving the LIBOR minus 0.2% from the outside investors, and Microsoft would be receiving 4.7%. And this transaction, again, is similar to the transaction done by the transforming a liability. Again, when a financial institution is involved, again, the financial institution will be receiving the 3% of this whole exchange. So again, instead of 5%, then they will be receiving 5.015% and giving to Intel 4.985%. As you can see, the difference here is 0.003%, which is the 3 basis that they actually get throughout this transaction. These are the quotes. Usually the financial institutions actually come up with a market maker, which means that they are the ones who come up with the basis. And as I mentioned earlier, they're the ones who take the 3 or 4 basis points. And so this is a quote given by the market maker, which are the financial institutions that makes these market makers. And as you can see, throughout the years of maturity, this is the bid and offer percent that they have set. And as you can see, the difference is either 3 basis points or 4 basis points. As you can see, is 0.03% or 0.04%, which is a 3 or 4 basis points. The swap rate is just basically the average of those two numbers. Usually when this transaction is done, if you take the previous example, they said that they will be doing semi-annually, which means that every 6 months they will be doing the transaction and the exchange. But if you consider that this day count convention, it is a specific time or days that it will be actually used to calculate the amount of exchange rates that they will be swapping. So if you look at the LIBOR, they're specified to have the transaction of the actual number of days that has passed divided by 360. And from the previous example, the 6 months from, I believe it was May to September, it's actually 184 days. So you basically will be doing 0.5, which is this fixed rate, times the notional value, which was $100 million, and then times 184 divided by 360, and that will be the exact amount of cash inflows that you will get. Confirmation is basically like making sure or giving actual, like it says, confirming the specification terms of the transaction. And this is basically the two firms coming together and agreeing with the exchange rates that they have been performed with each other. And the international swaps and derivatives have developed this master agreement that it is used to cover all the agreements between the two parties. And now governments are requiring central clearing to be used for most of the standardized derivatives. The comparative advantage argument, this states that basically you can say which corporation actually has the greatest advantage, or by choosing which type of rate they're gonna swap. So this is another example provided by the book. Imagine that there is a AAA corporation and a BBB corporation. The AAA corporation wants to borrow floating rate, and the BBB corporation wants to borrow the fixed rate. And if you look at this table, if they were to borrow in the AAA corporation, if they were to borrow a fixed rate, they will be borrowing a 4% fixed rate. For the BBB Corp, 5.2%. On the other hand, for the floating rate, AAA would be borrowing this amount and triple B this amount. And if you look at this table, you can clearly see that AAA corporation has a comparative advantage compared to the triple B corporation because they would be actually paying little amount of fixed rate and floating rate. So what they do is that oh, sorry. If you look at the difference between the AAA corporation and the triple B corporation, there's a 1.2% difference in the fixed rate, but if you look at the floating rate, it is 0.7%. And so you can clearly see that rather than choosing the fixed rate, the triple B corporation would be better to choose the floating rate. So they have a comparative advantage in the floating rate than in the fixed rate. So what they would do is that the AAA corporation would actually choose the fixed rate, and the triple B corporation would be choosing the floating rate, and then they would actually swap these two rates. As I mentioned earlier, the AAA corporation will be borrowing the 4% interest rate, fixed rate, and the triple B corporation will be borrowing the LIBOR plus the 0.6%, and then they would actually do the transaction in here. Now, when they do the transaction, triple B corporation would actually be paying 4.35% plus this amount, and this is less than the 5.2% that if they directly borrow for a fixed rate. So by doing these swaps, they could actually gain or be more profitable. As well as the AAA corporation, they would be yes, for the AAA, there would be actually, if they change the fixed rate of 4% into a floating rate, they would be actually borrowing a LIBOR minus 0.35%, which is 0.25% per annum. So in other words, these two corporations would actually benefit with each other if they actually take the comparative advantage of the interest rate and actually swap those interest rates with each other. So again, this is the transaction, the image of the transaction that will occur if they do the swapping, and this is when the financial institution is involved. Again, the financial institution either gets the 3 basis points or the 4 basis points, as you can see here. There has been some criticisms of why this concept. As you can see, the 4.0% and the 5.2% rates available to the AAA Corp and the Triple B Corp are fixed rate markets for 5-year rates. But if you take into consideration for the LIBOR interest rate, they are the floating rate markets for 6 months rates. So basically, when they do this transaction, the Triple B corporation will be the corporation that will most likely default the exchange because the LIBOR floating rate market are 6 months rates and the fixed rate markets are 5-year rates. So there's more a fluctuation between the amount of floating rate compared to the fixed rate. That's why they're saying that this is an argument that cannot be actually taken into consideration. So at this point in time, it is an adequate time to actually explain the nature of the swap rates. If you listened or take into consideration from the previous chapter, 6-month LIBOR is a short-term AA borrowing rate. And for the fixed rate, a 5-year swap rate has a risk corresponding to the situation where 10 6-month loans are made to AA borrowers at LIBOR. And this is because the lender can enter into a swap where income from the LIBOR loans is exchanged for the 5-year swap rate. This is the LIBOR swap zero curve concept, and basically it is talking about how to bootstrap this curve using the swap rates. And to have a better understanding, just consider that a new swap where the fixed rate is the swap rate, it equals to the swap rate. And when the principals when the principals are added to both sides on the final payment date, the swap is the exchange of a fixed rate bond for a floating rate bond. So if the floating rate bond is worth par and the swap is worth 0, then this is the same as that the fixed rate bond must also be worth par. So this shows that swap rates also define par yield bonds that can be used to bootstrap the LIBOR or zero curve. This is an example of bootstrapping the LIBOR swap curve. Let's say that for the 6-month, 12 months, and 18-month LIBOR swap rates are 4%, 4.5%, and 4.8% respectively, with continuous compounding. And the 2-year swap rate is 5% semi-annual. So in order to look for the variable R, which is the next 6 months LIBOR swap rate, then you would actually use this equation to find for R. And this is the answer that it gives for looking for the next swap rate, LIBOR swap rate. Now is how you can actually evaluate or value an interest rate swap. Usually at first time, interest rate swaps are worth close to 0. And then when time passes by, they can be valued as the difference between the value of a fixed rate minus a fixed rate bond minus the value of the floating rate bond, if you're paying in a floating rate. And alternatively, they can be valued as a portfolio or for rate agreement, which is FRA in other words, which I will be explaining later. So there's just to wrap up this slide, there are 2 types of ways to actually evaluate an interest rate swap. One is in terms of bonds. The fixed rate bond is valued in the usual way. As I mentioned earlier, the floating rate bond is valued by noting that it is worth par immediately after the next payment date. So if you look at this graph, right after the first payment date, the value is the same or par to the principal, and right before the payment date, it's the principal plus the payment of the floating rate at time t star. So if you look here, the variables, L stands for the principal, the t star is the time of the next exchange date, and k star is the payment of floating rate at time t star. So this is an example of how to value an interest rate swap. And let's say that there, a certain company or firm is paying a 6-month LIBOR and they're receiving an 8% semi-annual compounding fixed rate on a principal of $100 million. And the remaining life that they have is 1.25 years, so it's 1 year and 3 months. Yeah. And the LIBOR rates for the 3 months, 9 months, and 15 months are 10, 10.5, and 11% respectively. And 6-month LIBOR on last payment date was 10.2%. So if you do the calculations here, this is the fixed bond cash flow. So previously looking at the receiving of 8% since it is semi-annually compounding. Then it will be 4% in the 30 months. Then the next 6 months it will be 4% again. And then later, when the maturity is done, they will receive the principal along with the interest rate. And right next to it is the floating floating bond cash flow, and this is the total of all the 3 months, like the 1.25 years. And by taking into consideration the discounting factor, the number that you can actually get from here is by calculating the LIBOR rates for the 3 months, 9 months, and 15 months, which are this the 10%, 10.5%, 11%, by using the equation that I showed you earlier in here. So if you calculate, then this is the amount of discounting factor that you will get. And by applying the discounting factor to both the fixed bond and the floating bond, this will be the present value that you will be receiving for each of the months. And this will be the total. So the swap value, as I mentioned earlier, it is the difference between a bond fixed bond minus the floating bond. So here the first number that you get here is the fixed bond, and then the floating bond, and this will be the actual loss that you will get in doing this swap. The other way of actually valuing the interest rate swaps is through FRAs, the four rate agreements, and this can be valued on the assumption that today's forward rates are realized. So this will be done individually. Here again, the numbers here are gotten from the fixed rate, here from the floating cash flow. And then you will calculate by getting the net cash flows, and again the discounting factor. And when you apply the discounting factor to the net cash flows, this will be the present value of the floating bond. And as you can see, it gives the same answer to the previous type of valuation that we did for the bonds. Overnight index swaps. This is usually targeted by central banks to influence the monetary policy. The fixed rate for a period is exchanged for the geometric average of the overnight rates that the central banks have actually targeted. And if you look and see if there's actually an equal rate of the overnight index swap rate and the LIBOR rate, by picturing this situation, let's say that you borrow $100 million in the overnight market, rolling forward for 3 months. You also enter into an overnight index swap to convert the amount that you borrowed, to the 3 months OIS rate. And then finally, you also lend the funds to another bank, a LIBOR for 3 months. Now, if you do these transactions, and by looking at the results, you can see that the OIS rate is regarded a proxy for the short-term risk-free rate and the LIBOR. So there's actually an excess of the LIBOR over the OIS rate, and you can call this a LIBOR OIS spread. And usually it used to be at 10 basis points, but recently you can see that it has jumped to 364 basis points in October 2008. So actually, the previous question was if they were actually equal, but the answer is no, because the LIBOR rate, the OIS rate is regarded a short-term risk-free rate than a LIBOR. So far, I kind of explained the interest rate swaps, and another method of swapping is also by currency, so a currency swap. And again, this is an example. Let's say that there's an agreement to pay a 5% fixed rate on a sterling principal of 10 million pounds, and in exchange of 6% on a US dollar principal of $18 million every year for 5 years. Previously, for the interest rates, they don't use the principal, so they don't exchange the principal. But for the currency swap, they actually exchange this principal at the beginning and at the end of the swap's life. So here is the transaction if they were if a currency swap would occur. Here again, at the beginning of the swap's life and at the end of the swap's life, they actually exchange the principal. So they will be giving $18 million, and also they will be paying the interest rates of which was the 8% of the dollar. And they will be receiving this amount and they will be sending this amount. So this is the interest rate of the pound. This is the interest rate of the dollar. So this is the transaction that occurs when the pound and the dollar is swapped. And again, same as the interest rate, currency swap can be used to convert a liability in one currency to another currency. Also convert an investment from one currency to another currency. Also, comparative advantage exists for the currency swaps, but mostly it's because of the real values of the taxes. If you look at this example, General Electric would be paying a 5% rate for US dollars, but 7.6% in Australian dollars. The Qantas will be paying 7% in US dollars and 8% Australian dollars. And if you apply the comparative advantage concept, the General Electric would actually have a comparative advantage in US dollars rather than the Australian dollars, because if you look at the difference, there's a huge gap between the US dollars between General Electric and Qantas, while in the Australian dollars is minimal. So Qantas would be actually having a comparative advantage in Australian dollars and General Electric in US dollars. The same for currency swaps. You can actually value the currency swaps with the same method of interest rate swaps, either through a bond or a portfolio of forward contracts. This is an example of how you can actually evaluate the currency swap. Let's say that all the Japanese LIBOR swap rates are 4%, and all the US dollar LIBOR swap rates are 9%. 5% fixed rate is received in yen, and 8% is paid in dollars, and every payments are done annually. Here the principals will be $10 million and 1,200 million yen, and this swap will last for 3 more years. And one important variable or one important information that you need to know is the currency exchange rate. And in this case, let's say 100 yen, 110 yen per dollar. So if you apply this, this will be the amount of interest rates that you will be, interest rates in dollars and interest rates in yen. And this will be the present values of the dollar and the yen, and this calculation is done similarly to the way it was done by using the valuation of the interest rate bonds. And so this will be the total amount of the yen and the total amount of dollar. And here you apply the currency exchange in order to get the value of the swap of the two currencies. So as you can see, it gives out to be 1.54. This is a valuation in terms of frost. Again, you would do this individually by getting the cash flows of the dollar respect to the yen, and again, the result will give out to be the same as when you use the valuation of interest of bonds. Sorry. Uh, a swap can be regarded as a convenient way of packaging forward contracts, and although the swap contract is usually worth close to zero at the outset, each of the underlying forward contracts are not worth zero. So they are close to zero, but they doesn't necessarily mean that they're equal to zero. And there are some risks that you need to consider when doing a swap, and these are the credit risks. Swap is worth zero to a company initially, and at a future time, its value is liable to be either positive or negative. The company has credit risk exposure only when its value is positive, and some swaps are more likely to lead to credit risk exposures than others. And these are some of the questions that you need to actually take into consideration when actually doing a swap. What is the situation if early forward rates have a positive value? And what is the situation when the early forward rates have a negative value? And finally, these are other type of swaps that it briefly explains, but I do not think it's that important.
Okay. So there are two companies. So there are two companies, AAA and BBB. Let's use Excel. So there are fixed and then floating. So fixed is 4.4% and 2%. Floating is minus 1% LIBOR. Okay, LIBOR minus. So it is not LIBOR minus. It's less than LIBOR. And the LIBOR plus so LIBOR plus this rate. Okay, so there are two forms. And then this is AAA BBB. It is two boring names. So let's use this form is, let's say, 이화. Okay. The name of this form is SNU. Okay. Suppose there are two forms, 이화 and SNU. Okay. I make this one slightly bigger. Can you see, Chungyan, can you read this? Okay, so there are two forms. And then let's look at this situation and think about how we can make money. Okay? Suppose you are and then there are Hanyang brothers. Hanyang brothers is a kind of investment banker. Suppose you are an investment banker at Hanyang brothers, and let's think about how we can make money. Okay, Iwa can borrow money in the fixed rate. Okay, in the fixed rate means for the next several months, if Iwa can pay 4% per year, okay, for the next several years, they can borrow money. Okay, let's say it is 1 year. For the next 1 year, okay, if Iwa can borrow like $100, at the end, you can pay 104. If SNU borrow $100 today, then 1 year later, SNU should pay back 105.2. That's it. But they can also borrow at floating rate. If Iwa borrow $100 today, then Iwa doesn't know how much it has to pay back like 1 year later, maybe. It depends on interest rate. So what is the interest rate is, LIBOR rate is, Iwa will pay LIBOR minus 0.1%. Likewise, SN will pay some unknown rate, which will be realized shortly, plus 0.6%. Right? Then this is very interesting situation because whether they borrow money from fixed or floating rate, EY is always better. Okay, EY can pay just 4% here, and they can pay minus LIBOR minus 0.1%. On the other hand, SN should pay higher at fixed rate and higher at floating rate. Right? So definitely it seems that EY is better fund than SNU, right? Because when they borrow money, whether they go to fixed, whether they use a fixed bond, fixed rate bond, or floating rate bond, EY always pay lower rate. So EY is definitely better fund. But however, the interesting thing is the strength of the EY as fixed rate market is stronger than its strength in floating rate market, because in fixed rate market, EY pay what 1.2 point less than SNU, right? But in floating rate market, how much? EY's rate is, because LIBOR cancels each other, EY's rate is how much? EY's rate is 0.7% lower, right? So here EY is stronger by this amount, here is stronger by this amount, right? So although EY has absolute advantage in both markets, EY has more comparative advantage in fixed rate, while even though SNU is in absolute disadvantage, but if SNU has comparative advantage, compared to fixed market, comparative advantage in floating rate market, this creates money making opportunity for investment bankers. The difference is, let's say, okay, so gap between the two rates is 0.5%. Okay, so EY has 0.5% comparative advantage in fixed market, and SN has 0.5% comparative advantage in floating rate market. Okay, and then how can we make money? Then you can go to these two companies and suggest following this. Okay? If you borrow money at floating rate, you should pay LIBOR minus 0.1%, right? Then you can suggest okay, I will go to floating rate bond market and I will borrow money for you. Okay. Then of course, because you can pay only LIBOR minus 0.1%, then maybe you can suggest that I will pay you LIBOR minus 0.1% minus slightly less than that rate, something like that. If you suggest that rate, we can finance our project at low rate through you, through Hanyang Brothers. So they are maybe willing to do the transaction. Okay. So basically, for Hanyang Brothers, okay, you go to EY and then you borrow money. Okay. So borrow money at this rate. So you have to give money to EY this rate, right? LIBOR minus, so for Hanyang Brothers, okay, provide to EY this rate. Okay. Okay. And then, but instead you suggested that, okay, but you can borrow money at 4%, so therefore, what you can in turn also suggest is, okay, I'll give you money, I'll finance money from the floating market, and so on, and give you money. But since Iwa can borrow money fixed rate, so I asked Iwa to borrow money through 5% at fixed rate bond. Okay. Then maybe you can also suggest that if you borrow money 4%, then I will maybe give you 4%, 4.1%, something like that, slightly higher than that to Iwa through that. Okay. And then 4%. LIBOR plus. Essentially floating. Okay. And then now you can go to SNU. SNU, so the SNU can borrow money at 5.2% at the fixed rate market. Therefore, you can suggest, okay, you can suggest SNU that, okay, I will get money maybe lower than 4.2%. Okay, maybe slightly lower, like 5.19% or something like that. Okay, then SNU will say yes to you, right? Because you will get money, cheaper money from cheaper than 5, lower rate lower than 5.2%, right? So actually it is a slightly lower. Yeah? You pay slightly higher. Okay? Because I mean you provide money to you at this rate, so they can already finance this rate, so you have to pay slightly lower rate. When you borrow money from EWA can borrow money 4%, so you can pay slightly higher money this one. Okay? And then SNU. Slightly lower rate. Okay? And then again, now instead you can ask SNU, okay? Please borrow money at floating rate market. Okay? SNU. Now this one is plus LIBOR. Okay? You borrow, and then you have to pay a slightly higher rate. Okay? If you offer slightly higher than rate this one, then SN will borrow money from at this rate and then give you. Okay? Give you, and you will pay back slightly higher rate, and basically SN you can make money also as well, like small rate. So you use the two operations. Then let's see what happened. You provide EWA at this rate, and then therefore, okay, borrow from EWA at this rate. So you have this money, right? And then, okay, so you provide EWA at this rate. Therefore, when you borrow, okay. Wait. Just a moment. So you borrow, so you have to put, okay. Since it is borrow, so it is borrowing contract. So it is 1, right? Sign of the direction is -1. It's 1, -1, right? So it is borrow. You have to pay back this money, right? So it means that one is right. So through this transaction, basically, you can make money by 0.5%, right? 이상하네. Yeah, 0.5%. Of course, I mean, you will make money slightly lower than 0.5% because you split small this commission to each part. Okay, but point is that basically you don't take any risk because you borrow money from here and give it to this part, and borrow money from this one and give it to this part, right? So basically you don't take any risk until you can make 0.5% for every transaction. So you can make arbitrage profit. Okay, so this is kind of a way of making money, like arbitrage money, right? No risk. Any question? 질문 있나요? Lori, do you know what's going on? Actually, this is very important. This is what, of course, this kind of opportunity is not frequent in the interest rate market because everyone is looking at this kind of opportunity. But in the slightly more, it is very simple contract, right? But if we have a multiple layers of this kind of transaction and if we add a derivative contract, actually this kind of opportunity exists. Okay. So once you find this kind of opportunity, then you can discuss the matter with the salesperson, and salesperson go to EY and SNU and suggest the deals, and we have to accept, right? This because to them, to EY and SNU, it is also their arbitrage opportunity. Yeah. 뭐 그걸 빌리고 싶지 않을 수도 있지. 예. 어쨌든 저렇게 포지션이 있으니까 예, 이미 하고 있다는 거 아니에요. 예, 그러니까 마켓에 있는 뎃을 좀 줄이고 내가 주겠다 뭐 이런 식으로 말할 수 있는 거지. 예. So anyway, the idea is that I don't do basically anything. Okay. So thing is that I borrow. Okay. So let's think of more straightforward way. Basically, I borrow money to SNU, right? And by borrowing money to SNU, I give this money to EWA. Right? I borrow SNU, LIBOR plus 0.6% and give to EWA at this rate. So basically, I lose money. Okay? I lose money by 0.7%, right? I borrow money at SNU and give money to EWA. But this, my borrowing is high, so I lose money 0.5%. But on the other hand, I borrow money from EY at 4% and I give exactly the same money to SNU at 5.2%. So I make money from that country 1.2%. And I make money by this transaction, fixed transaction 1.2%, and I lose money 1.7%. Therefore, and then in that I make money 0.5% every month. So the point is, I don't even have to go to fixed rate bond market or floating rate bond market because I use this money to pay this one, and I use this money to pay this one, right? All I have to do is like changing it. In reality, I cannot, of course, make 0.5, but it should be advantage to EY and SNU. In that case, what I can do is maybe I give this one slightly lower rate. Okay, slightly lower rate, and then maybe provide the SNU at the okay. 이게 아니구나. 네. 다시. 이상한데. 다시. 됐다. So, okay, let's you provide this. So I provide this rate, right? I provide you. So what I can do is I can provide a slightly lower rate to EYU. In this case, I can pay some kind of this rate, right? I can pay even lower rate to EYU. When I provide SNU, if SNU go to the market, they can borrow at 5.2%, so it should be better for SNU. So what I can do is I pay slightly lower rate by this one, okay? Then in this case, instead of making 0.5% every transaction, I make money 0.39% every transaction. Instead, EYU and SNU can make 0.01% for every transaction, so it is good for them. Okay. I can even split this one same to each part, right? And then I can make this one lower, or maybe I can make this one higher. So I can split the money to each part. Then it is good for everyone. 이해가 안 어렵죠? 네. In fact, exactly same thing, same example. Actually, very similar logic can be applied to currency rate swap. Oh, by the way, this money is exactly same to this one, right? So the amount of the arbitrage profit is exactly same to the difference of this amount of comparative advantage. So if there is no arbitrage opportunity, if it is zero, it means that EYU and SNU shouldn't have any comparative advantage in each market, in equilibrium. Okay. And let's go to the currency swap. What is the example for currency swap? Okay, here it is. Let's do the same example. Yes. This kind of simple opportunity doesn't happen, but when there are derivatives involved and then multiple layers of contract involved, this kind of opportunity do exist. Okay, this is a very simple example, but in real life there are more complicated deals. Okay, there can be like a hidden derivative is hidden in this contract. So yeah, in order to figure out these numbers, after you have to go several lines deeper into their contract. So that kind of opportunity do exist, but in more complicated way. And then now USD AUD. USD AUD 5%, 7%. Okay, it is exactly the same, very comparable example. Again, suppose there are two firms, EYU and SNU, and let's say EYU is American company, SNU is Australian company. Okay, and then when EYU borrow money from US market, they pay 5%. When EYU go to Australian market, and they borrow money in Australian dollar AUD, they have to pay 7.6%. On the other hand, SNU is Australian firm. When they go to US market, they pay 7%. When they go Australian market, they pay 8%. Again, EY is definitely better firm than SNU, right? It pays lower rate in both US market and Australian market, right? But thing is that since EY is American company, EY has 2% advantage in US market, but since SNU is Australian firm, it has 0.4% comparative advantage, because in US market, since SNU is Australian firm, and then US market doesn't know Australian firm that much, so Australian firm pay even higher rate. But instead in Australian market, although EY is good, SNU is more recognized in Australian market. So the gap between EYUA and SNU is lower in Australian market, right? That's the point. So again, you can make a deal. You will propose a deal. So what you can do is, okay, you can go to EYUA that, okay, I can borrow money for you lower than, okay. Okay, so what you can do is, let me, Hanyang brother, copy and paste. Okay, what you can do is, you provide EYUA, right, at this rate. Okay, at this rate, LIBOR or this rate, but it should be slightly lower. Okay, then they will accept, right? Because you are have to pay 7.6%, but you are willing to raise money slightly less than that, and they are willing to accept this deal, right? But instead, you can ask EYUA that please borrow money for me at 5%. 5%, right? And of course, you are willing to pay slightly higher rate than this. And then now you go to SNU, say, okay, if you have to borrow money 7% in US market, then I'll pay lower rate in US market than that one. And instead, you can borrow money from SNU in Australian market at 8%. Then aha. Okay, so you can make, through this deal, you can make 1.6% for every transaction without any risk. And the amount of this 1.6% is exactly the difference between the comparative advantage of two deals. Again, you don't have to borrow any money from either US market or Australian market. What you can do is you borrow money from SNU, okay, and give that money to EYUA, okay, right? If you borrow money and give this money to EYUA, because both of them are same Australian dollar, so you this Australian bond, so basically you borrow, you basically give this Austrian money to EYUA, okay, which you receive money Australian dollar from SNU and give money to EYUA, and through this deal basically you lose 4%, right? Because you borrow at 8% and you lend at 7%, 7.6%, right? So basically you lose 4% in every deal. But on the other hand, you receive money from EYUA and give that money to SNU, and then when you take money from EYUA, you pay only 5%. But when you give money to SNU, you actually receive 7%, and therefore you make money 2%. So in that, you lose 0.5% in Australian dollar and make money 2% in USD. So basically, you can make money 1.6%. So every deal, again, you can make arbitrage opportunity. Actually, this kind of deal is more often than this one. This kind of deal, this kind of simple deal is not that easily available in the market. Okay, you have to go into the layers of the derivative and those things. But this kind of deal is more often, right? Because of the international fragmentation, global financial market. Of course, global financial markets are integrated, but not that integrated. It is still not one market. Therefore, still that kind of comparative advantage do exist. So this kind of opportunity is more available. Any question? Okay. Okay. Then the next question is, okay, this kind of arbitrary opportunity. So let's then this is arbitrary opportunity, and this is basically reason why there exists swap contract. Swap contract exists because some firms has comparative advantage in fixed rate market, some firms have floating rate advantage in floating rate market, so they have incentive to trade each other. Another possibility is some firm has a fixed rate debt and they may want to change it to floating rate debt. One idea is, of course, they can retire fixed rate debt and issue floating rate bonds, but this is too complicated. Instead, they can simply go into swap deal and then change the nature of the cash flow, and which is cheaper and easier, right? And then, of course, there is also reason why swap contract exists in currency market, FX market, because some U.S. firm may need money in Australian market, may want to issue money in Australian market, and maybe Australian firm may have reason to issue bond in U.S. market. Right? And then next, we have to know how we can do the valuation of a swap, and then this is swap contract. And then I think there is a good example. There is a valuation of, and then when you do the valuation of swap, there are already another two ways. One is using one idea is using the swap contract as a transactional bond. Another idea is to regard the swap contract as a transaction of the forward rate contract, basically. Valuation of using bond. Example. Oh, by the way, I think we need to take 15-minute break. But before we taking break, let me make some announcement of homework. I checked your homework midterm exam, and then I still not sure whether you did your homework. You completely understood your homework, or you simply maybe copied other people's homework or download some code from web. I'm not sure. So in order to check, I want you to write a manual for your code. Okay. So you have a code, so you have now write down explanation about your code. And that explanation should be very easy so that even high school students should be able to understand it. Okay? So please write line by line manual for your code. Okay? For your code in midterm exam. Even high school students should be able to understand it. Instead use Korean, English, whichever you like. Okay. 한글로 하든지 영어로 하든지. Okay. And then you will be asked to present your manual. Okay. I'll ask you to present your manual. And then please submit your manual via this email. Okay. And this is homework. Due next week. Due next week is pi. Any question about homework? No. Okay. 숙제에 대한 질문 없죠? 그래서 어차피 본인들이 한 거니까 이렇게 매뉴얼을 만들어 보는 거 좋아요. 안 잊어버리고. 예. 어차피 본인이 만든 코드 나중에 금융권 가면 자기가 또 쓰게 될 거거든. 예, 남이 만든 것보다 본인이 만든 걸 쓰는 게 쉬워요. 그래서 그때를 대비해서라도 만들어 놓으면 좋겠습니다. Okay, thank you, and let's take a 15-minute break. 3 months later, we leave 1.5. 3 months later, we receive 1 more 0.5. and 3 months later we receive 1.5 actually. But we assume that we add $100, so let's assume that we receive $100 plus 1.5. Okay, and then floating rate bond, we receive 1.45 next month, but we don't know what to do the cash flow here. We don't know what to do the cash flow here. But let's assume that at the last cash flow we add $100, notional amount. Okay, and that value of this cash flow at this point is 101.450. Okay, and then therefore the value of this, so this is L plus K star. Okay, therefore the value of this present value of this one is this one. The present value of this one is this one. So the distance between this is this one. So I receive this one, and actually I receive floating. I pay fixed. Therefore the value of my swap position, which I receive fixed and give floating, is in which I receive floating and fixed 0.5117. You know what I'm saying? Yeah. Rory, do you know what I'm saying? It's very important. Let's read this concept carefully. Okay. Receive 6 months LIBOR. Okay. So I receive floating. LIBOR is floating rate, so I don't know how much money I'll receive. Except 6 months later. Except the first coupon, I don't know how much I will receive. And I know how much money I have to pay because I have to pay fixed and receive floating. And then principal is $3 million. Remaining life is 1.25 years. In swap contract, cash flow is exchanged every 3 months. So now you are here 0.0, okay, and 3 months later is 2.5. Okay, so you are at 0.0. Okay, the contract ends. I have to go one more. 하나, 둘, 셋. 죄송합니다. In this case, in swap contract, is strange. Okay, 6 months. Okay, in this case, it's 6 months contract. So they receive on every 2 times. So you are now, okay. Okay, you are now 2.5, and then okay. In this swap contract, they receive money every 6 months, and then you are actually in the middle. Okay, you have 3 months to go. Okay, so if you are at the beginning of 6 months, it would be slightly easier, but you are in the middle of the cash flow. Okay. So the first you exchange the first cash flow 3 months later, and then you explain next cash flow in 9 months later, and you explain exchanging next cash flow in 15 months later. Okay. Now, what is the interest rate? Okay. Okay. LIBOR rate for 3 months. So let's say LIBOR rate. LIBOR rate 3 months is in this case 2.3%, 2.8%. Okay. And then 9 months, which is 0.75, is 3%. And then 15 months later, okay, the interest rate is 3.2%. Okay, so this is LIBOR rate for the next 3, 9, 15 months. 귀찮아. 단축키를 써야겠고. Okay. So we can calculate discounting factor, D factor. 오늘 브라우니안 모션 배우려고 했는데 시간이 안 되겠네. 그렇죠? Discounting factor is EXP exponential minus this one multiplied by this one. Done. And then I need 진짜. Okay. So this is 99397. 에? 왜 숫자가 다르지? 이거 교과서가 이상한데? 왜 수가 다르지 이거? This is LIBOR rate. 나 이 책에다가 숫자 그대로 썼는데 왜 숫자가 달라? 교과서 한번 확인해 볼래요, 누가? 이상하네. 뺐지. I don't know why. This book has some typo.
한국어 책이 예제가 좀 숫자가 다른 거지.
이건 책이 숫자가 또 다르네. 잠깐 이 책에 나온 걸로 한글 책에 걸고. 이게 10, 10.5, 11. 그러네. 이렇게 하니까 책은 이 한국 책은 또 맞네. I think anyway, I think the textbook is wrong. Some textbook is wrong. So somehow the PPT file is wrong. Well, they can make mistake. I don't think her made mistake. Her TA or RA made mistake. And then there are mistakes. So this is discounting factor. Okay. And then fixed rate bond. Okay, fixed. Okay, so reflection. In the fixed, notional amount is 100, right? 100 billion. What? Okay, notional is 100 billion. And then to pay 3%. Okay, 3%. So they receive every 6 months. So in fixed, in contract, what they receive is this one multiplied by this one. Okay, 나누기 2 divided by 2 because it is every 6 months. So every 6 months, because fixed rate is 3%, so per year they receive 3%. So 6 months they receive 1.5%. So every 6 months they receive this one. So we have 3 months to go. So 3 months later they will receive this one, and then they will receive this one, and they will leave. Okay, they will leave this one same, and they will leave this one. Okay, this is something I have to pay. Okay, in the fixed rate part, fixed rate. How much I receive? Receive is the okay. In the floating part, in the 3 months ago, okay, I have 3 months to go. To receive cash. First, floating cash flow, which is fixed 3 months later because it is every 6 months. So 3 months ago, the LIBOR was how much? LIBOR was 12.9%. Okay, 6 months ago. Okay, so 3 months ago, I know I will receive 100 multiplied by this one divided by 2. So recent LIBOR was what? 9%. So 3 months later, I will receive multiplied by am I right? I think this number is also wrong. This is too high. It is not 12.9%. This should be okay. I think this is typo. It is 2.9%. Okay, this is typo. Okay. So I receive cash flow 3 months later, which is fixed 3 months ago. 3 months ago, fixed rate, which is 3 months later, was 2.9%. So I will receive $1.45 million 3 months later, which I know because it is fixed 3 months ago as a 6 months contract. Problem is that it is floating rate contract. I don't know what would be interest rate from 3 months later to 9 months later, which is not known. Okay, so this is known. Because I pay, okay? I minus. What I do is I do little trick, okay? At the end of the 15 months, which is less contract, I add $100 each side. Actually, I subtract $100 and I add plus $100. It is same money plus minus, okay, cancel out. So what I do is I transform this one as fixed bond. I generate bond such that, okay, this is same to this one, this is same to this one, and this is same to this one, plus $100. Actually, minus $100. I substitute minus $100, and then what I do is same, and then same, and then this one plus okay. So anyway, what my trick is that I subtract $100 and I plus $100. So basically this cash flow should be exactly the same to this cash flow, right? And then now it is very easy. We know the value of this contract, right? Value of this cash flow should be now. So value of this cash flow, okay, valuation. Okay, value, okay. Okay. Now, value of this one is, we know it should be 100. Okay. Value of this one should be 100 plus 1.5, right? At this point. Because as I told you, I don't know how much money I will receive next month this one, but at least at this point, the future cash flow should be equal to $100. Because if I put $100 in the bank, I have exact same amount. But I have additional small cash flow 145, right? Right? Okay. Therefore, at the 3 months later, value of my floating rate bond is 101.45. And then we can know what is the present. This one, okay? Okay. Now, since discount factor is this one, so we can calculate present of this one, present value of this one. We can simply multiply this one and this one. Okay. So present value here is at point 0. This one multiply this one by this one, right? This is right. Okay. Okay. Right. So value of floating rate bond is therefore 100.45, right? And the value of this fixed rate bond is very easy. This is known. We have discount factor, this one. So value of this fixed rate bond is sum product of this one and then this one, right? So therefore value of my position is simply this one plus this one. So value of my point is $0.27 million. So I think this slide is wrong. They messed up this discount factor. Okay. So this is very easy, right? Again, what I do is, this is contract. I will receive this one. Probably I know this one, but I don't know this one. As a trick, I add $100 to this one. Okay, but they cancel out, and then we know value of this contract because it's fixed. We don't know value of this. We don't know the cash flow of this one, but we know this unknown part should be 100, and known part is 1.45. So we discount it, and we know the value of floating rate bond. So we know the value of my position. Right. This is very important. 질문 있어요? 유재민 학생 질문 있어? 무슨 말인지 알겠지? 네. 라이브는 이미 주어져 있어요. 네, 라이브는 이미 주어져 있어요. 그러니까 이자율이 이미 주어져 있다고 생각하면 돼요. 6개월 후에 6개월 디스카운트 이런 거 시장에서 정해져 있다고 생각하면 돼요. 이미. 그러니까 이걸 우리는 텀 스트럭처 오브 인터레스트 레이트라고 하지. 이자율 기간고 스팟 레이 커브예요. 이거 뭐 스팟 레이 커브 이미 주어져 있는 거지. 이자율 하는 거. Rory, do you have any question? Only one. Okay. Oh, about discount factor. Okay. This is given in the market. In the market, interest rate is given as this one. So it is just data. From this data, I got the discounting factor. Okay. Just doing continuous compounding this way. This one multiplied by this one, and then minus and exponential. So you can regard the discount factor as just data. Any question? So this is 1A. Okay. Another method is that. Another method is actually more intuitive, and actually this is a better method. So another method is also intuitive. Another method is we don't know what would be this part. We don't know, but in the market, there is a contract that changes this unknown cash flow into the known contract, known cash flow. Okay? So in the market, people trade. Some people give this one, and some people receive this one. So it is like just one period swap contract. So one period of day in the market, they trade one cash flow with no cash flow, which is basically called as forward rate agreement. In the future, you don't know interest rate, but that can be forward rate. Okay, and since we know what is the equilibrium price for this unknown cash flow, simply you use that value and discount it, and you have done. Okay, so anyway, in the market, what I mean by that, it is unknown cash flow, but there is a price for this unknown cash flow, and simply you plug that price of unknown cash flow, and then do the discount. That's the idea. Basically, that's the idea. And that price is basically forward rate, and that forward rate is, as we learned, that forward rate can be calculated from this spot rate curve. So idea is, if you take a look at this part very carefully, then means that you know what is the value of this future cash flow, and then